All right, good morning, guys. Welcome to math class today on March 20th, Friday. Woohoo, Friday! Here is today's entrance task, and make sure you pay attention to the directions to solve and graph. So you're probably going to need a little bit more space than how I have them written right here, because you're going to solve the inequality to get x alone, and then you're going to graph the solution on a number line. So pause the video, take a few minutes. It'll probably take you about a minute a problem to solve and graph each one of these, and then hit play again after you're done, and you can check your answers. All right, we're back. I'm sure each and every one of you did a nice job doing that. So let's go ahead and take a look at your answers on the entrance task. So here are the answers. I'm not sure if you can hear Aubrey crying in the distance. She's actually crying through the closed door. She is a loud crier. Hopefully she'll settle down pretty soon. So here you go. Here is your answers and the graphs to each one of these. If you're looking at this one here first, x is less than 2. Gary the Gator is chomping the 2 here. So since he's chomping the 2 is larger than what my answer is. So my answer is less than 2, which means my answer is all the numbers smaller than 2. Less chalk here, less chalk for my dot. Less chalk here, less chalk for my dot. Again, it's a less than, shade below. Here, more chalk for this greater than, or it's a less than or equal to symbol. But x is on this side here, so it's more chalk, so you got a solid circle here in the graph. And Gary the Gator is chomping my answer x, meaning that my answer is larger than what 4 is. So I put my arrow to the right to all the bigger numbers. And here, finally, less chalk, so it's an open circle. Gary the Gator is chomping my answer x, so my answer x is larger than 13 is, so I shade all the answers larger than 13. All right, so there's the answer to your ET. Let's next, I did not post your guys' answers to the homework because I thought I would do the final part of them with you guys and graph them kind of together here, so that's what I'll do. So we did number 1 together yesterday at the end of the lesson. So number 2, here's all my algebra to get x is less than or equal to 2. Now, is this going to be less chalk or more chalk? More chalk, Mr. Hardenstein. Good, class. More chalk. Yes. So we're going to put a filled in circle here. And my answer is smaller than what 2 is. Gary's chomping the 2. So all the answers that are smaller, and that would be my arrow. Okay. Moving up here to number 3 and number 4. Notice I counted by 60s here. So that's a good number line. Count by 60s. That's the easy way to fit it all on there. Gary's chomping the number 60. More chalk to make this symbol. Okay, so I want to include 60 because my answer is less than or equal to 60. So it could equal it. So I'm going to fill in the circle. And my answer is less than, so I want all the numbers smaller than that. Number 4. Gary is chomping the x. It's less chalk. It's at -3. Less chalk, open circle. So, and Gary's chomping my answer x, so my answer is larger than -3 is. So I want all the numbers larger. Again, it's not filled in because I don't include -3. I want everything just that's bigger than -3. Okay, and then finally here, the last 2, 5 and 6. Here counted by 16s. More chalk at -16, so it's a filled in circle. And Gary's chomping the -16, so -16 is larger than what my answer is. Therefore, if -16 is larger, my answer is smaller. So it would be all the numbers smaller than it. By the way, another trick some people use is you can rewrite your answer so that x is first. You just have to make sure Gary chomps the same thing. So I can put x in -16 and make sure Gary is still chomping the -16. And as long as you write x first on the left, this arrow, or the less than sign, will kind of be like an arrow telling you which way So it's kind of pointing to the left. It tells you which way to shade. It can get confusing, I think, if that's the only way you think of it, but it's another good trick to fall back on. Okay, and then finally, this last one, my answer was x is less than 4 8/9. So I'm going to go ahead and I counted by 4 8/9 on my number line. Not very common to do, but it's correct. You won't lose any points for doing it that way. Gary the Gator is chomping 4 8/9. So that means that's larger than my answer. My answer is smaller. So I would shade that way. And there's all my graphs to the homework from yesterday. So hopefully that all makes sense, and I took enough time explaining it so that you guys understand it. And now we're going to move on to notes on page 6. Notes. Yay! Hopefully you guys beat me to the punch and already said yeah. If you notice on these, it said no negative coefficients, and that meant no negative coefficient on the x term. Okay? And that's going to be, I told you, I think the first lesson, that it's like 90% exactly the same. Well, today's lesson is that one part of the 10% of the problems that are different. Hence the title of today's notes, The Only Thing That's Different. All right? So, let's take a look at this. I told you guys before that algebra would keep everything the same, and that was mostly true, but something funny happens sometimes when you start getting into dealing with some things with negatives. So let's start out with a true statement nobody can argue with. -1 is less than 3. And everybody would say, without a doubt, -1 is indeed less than 3. And for the most part, if I add the same thing to both sides, if I add 2 to both sides, I get 1 is less than 5. That's still true. I can take away things from both sides, or I can, let's say I take away 4 from both sides, take away 4. I get -3 is less than 1. I get all these things that are true statements. All right, and I could multiply both sides by 4. Let's say -12 is certainly less than 4 is. So for the most part, all of these different algebra steps hold true, that I continue to get true statements when all this happens. However, one thing that kind of throws a wrench in everything is if you decide all of a sudden to divide, let's say, by a negative number. If I divided both sides by just -2, I just picked that number randomly. Negative divided by a negative is a positive. I get 6, and 4 divided by -2 is -2. If I kept that number in there, or kept the sign in there, this is telling me 6 is less than -2. 6 is not less than negative. Gary's chomping -2 here. This is absolute garbage. So this happened, and mathematicians all simultaneously everywhere in the world found a corner and threw up in it, and started going back to the drawing board of, oh no, what do we do now? Then some brilliant guy, I think he went by the name Haudenstein, I think he was Austrian, and some old guy came up with the idea, aha, I got it. What if when we divide by a negative number, or when we multiply by a negative number, we just reverse the inequality. In other words, switch Gary around. Turn him right around. Alright? And you could see even in this one up here, if instead they would have followed that rule, they said, oh, we divided by a negative number, so I get 6 and -2 here. If I just reversed Gary around and made him go this way, aha, everything's all better again. So that became a rule right there, that became a rule for inequality. So if you, solving the problem, perform an algebra step where you divide by a negative number or you multiply by a negative number, you must remember to reverse the inequality. Okay, so that's kind of important for sure when you're doing these. Okay, so how's this looking a problem here? Well, let's say, we'll do one example. Example 1. Let's say we're solving the problem 7x plus 6 minus 10x is, let's say greater than or equal to 33. Alright, so we go ahead here. Let's combine like terms. Get negative 3x plus 6 is greater than or equal to 33. Subtract 6 both sides. Negative 3x is greater than or equal to 27. Next algebra step, divide by negative 3. That's going to be a key. You have to notice, just like class, you guys can't see anything I'm doing. Is that better? A little bit. So I combined like terms, negative 3x plus 6, subtracted 6 both sides to get rid of that 6, then divided by negative 3, where I just yelled it and you couldn't see it. But that key, you have to recognize whenever you divide by a negative or multiply by a negative, you must remember to take that inequality sign and reverse it. So I flip it around so it goes that way, and that's my answer. You go ahead and graph it on a number line. Hit negative 9, solid circle, and my answer is smaller than negative 9. Again, you can't quite see that. There's my answer. Okay? Alright, so the only difference is that one rule right there. On your homework problems you're going to try for tonight, homework, obviously everything's homework. Yeah. For the next page, you're going to try page 7 here. This rule, this is just solve and graph, it's not going to come up on all the problems. It's only going to come up on 2 or 3 of them. So, half the homework tonight is going to be just like it was the day before. And then there'll be a few of them where you're going to end up using that rule. All right. Good luck. Have a great weekend, and we'll check in with you guys on Monday. Have a good weekend.